In today's video, I'm going to discuss with you physics. First chapter. This is day 1. In day 1 of physics, we are going to start with units and measurement, the most important chapter in physics. This chapter is going to be creating a very huge importance in your life in every further chapter, whatever chapters that you are going to be discussing in the further chapters, whatever kind of questions you are going to do in every chapter. Basically this chapter plays a very important role because this chapter talks about units. This chapter talks about measurement. We require measurement, we require units everywhere. So let's start the chapter without wasting any time. So first most important thing that I would like to discuss in this chapter is you must know about what is a unit, because when you are talking about this chapter, the first most important thing is unit, right? So we have different types of units. First, there was a previous system of unit. There are different systems of unit. Unit is nothing but what you are supposed to multiply multiple times. Okay, for example, I have 1 kg mass of something, so 5 kg means 1 kg multiplied by 5. That is the actual mass that an object is having. So I'm comparing quantity. Units are nothing but comparison. You're comparing some quantity with another physical quantity which we have set a standard. We have chosen a standard quantity. Okay, for example, you have seen when you go to shops, they use 1 kg block on the balancing weighing scale. When they have this kind of weighing balance, the side they put a 1 kg block to compare the mass of the side object. This is 1 kg and this is also 1 kg of some object. Then the weighing scale will be balanced. So you are comparing this mass using this mass. Suppose this mass is 2 kg. That means two 1 kg blocks. You are going to add 1 kg, two blocks. So 2 kg is nothing but 1 kg multiplied by 2. This is one standard. You have chosen this. The standard is chosen by you. You have decided. This is decided by you. You have decided that two such masses create 2 kg. So that you're comparing the quantities. That is the meaning. So system of unit, there is one standard system of unit because every person can use a different system. Somebody wants to use a stone to measure weight, somebody wants to use something to measure weight, right? So that's why we created a standard system of unit. Otherwise different people used to use different system of unit. For example, some people used to use system of units. I will tell you some system of units that is already that existed. One is CGS. CGS means whenever you are measuring the length in centimeter and mass in gram and time in second, that is known as CGS unit. So centimeter, gram and second. So CGS means centimeter, gram and second. Then some people use MKS system. You may like CGS unit, but somebody else may like the MKS unit, right? So MKS means meter, kilogram, that is kg, and second. So some people may prefer this, whereas other people, like you go to US and all, people still measure length in feet or foot and pound, and time is measured everywhere all over the world in second. So some people prefer a different unit. So now what is the standard? What is the system of unit that we must use? Should we use the CGS unit? Should we use the MKS unit? Or should we use the FPS unit? That's where the problem starts. So that's why there came up a body which is known as Systeme Internationale. Systeme, this is a French word, Internationale. Systeme Internationale, which means International System of Units or SI units in short. So they created SI units. SI units is nothing but international system. In entire physics, whenever you use anywhere, in any chapter you see unit. you have to use only these units. You are not supposed to use any other unit. Even if the question is given in some other unit, please convert it and then solve it. Otherwise your answers will be wrong. So that tells us the value of these units. For example, if you see here, let me tell you. So mass, what all are there? There are only 7 quantities. Entire physics, I am telling you clearly, in entire physics there are only 7 units that we are going to use. There is nothing else except these 7 things. Whatever else you are studying apart from these 7 things are combination of these 7 things only. So these 7 things are the most important things. So what are they? One is mass, other thing that you can measure is length. You can either measure mass or you can measure length, or you can measure time, or you can measure temperature, temperature, or you can measure amount of substance, current, or you can measure current. You can measure amount of substance, or you can measure luminous intensity, how bright something is. There is nothing else except these. Remember, these are the only 7 things that we are going to use in physics. And whenever you represent any quantity using these, I want to show what something is made up of, whether it has mass in it, whether it has length in it. That is called as dimensional analysis. So I use alphabets like these inside square brackets with powers, how many times that quantity is repeating, to represent it. For example, mass is represented with capital M, length is represented with capital L, time is represented with capital T, temperature is measured with K because Kelvin. I will tell you what are the units. Current is measured in ampere A. Amount of substance, generally we write. Luminous intensity is measured in these symbols along with brackets. When you write them to show what all a quantity is containing, these are known as dimensional analysis. Dimensional analysis. Dimensional analysis. Okay, so I will write it down properly for you. These are only known as dimensional analysis. These are nothing but dimensions. So dimensions we are using to analyze something, analyze whether our equation is correct, all those things. I will tell you the advantages of dimensional analysis now, but before that you must know about what are the advantages of this. Okay, so I will tell you, don't worry. So mass, what is a unit? Whenever in physics you get mass anywhere, what should you represent it by? You are supposed to represent it by, mass is always written in kg. Whenever you get mass in gram, for example, you want to find force requires mass, so you are going to use only kgs. Length is measured always in meter, time is measured always in second, temperature is measured always in Kelvin, current is measured always in ampere, amount of substance means mole, how much of something is present, luminous intensity means candela. Don't worry, I will explain all these to you in detail. So there is an international weight, prototype of weight. Okay, so there they have placed 1 kg of mass. Whatever is the mass of that 1 kg block, that is considered as a standard 1 kg all over the world. So that is 1 kg. You don't have to know the definitions of these are not asked, but still I'm just telling you. Length is nothing but how much distance light is traveling in 1 by 3 lakh of a second. So that is considered as 1 meter. Time is second. You know, time is some international, there is some atomic clock. Okay, so that measures the time. Basically these are not required, you don't have to know the definitions, but what I'm trying to explain you is these units must be remembered and these must be in your head. There are 7 fundamental units. One, 2, 3, 4, 5, 6, 7. These are the 7 fundamental SI units. Apart from these, there are also something known as complementary units. Complementary units, or supplementary also some people tell. Supplementary units. These are nothing but radian, steradian. These are radian and steradian. Steradian is nothing but solid angle, radian is nothing but plane angle. So plane angle, measure of a plane angle is called as radian, and measure of a solid angle is known as steradian. Plane angle radian is nothing but opposite arcs. See, suppose I have a shape like this. This is my angle. Here I have an angle. This arc divided by this arc, this side divided by this radius length is called as this radian angle. And steradian is nothing but solid angle. So we take area. We have an area which is enclosed by a three-dimensional angle. So there is a 3D angle. So this 3D angle will be equal to this area divided by this radius square. This radius square, that is known as steradian. So these were about the unit. Okay, so you must know what is system A international, and this is dimensional analysis. I will show you how it is used. So uses of dimensional analysis, I will just write down. One uses to derive formulas. You can derive formulas of quantities that you don't know. Okay, you can check if the formula is dimensionally correct. Check accuracy of formula. And also so basically these are the two uses of dimensional analysis. You can convert units also. For units also it is used, but these are the main two uses. And what are the so these are the concepts of dimensional analysis. And next let's talk about and principle of homogeneity. So that is also there. Principle of homogeneity means you can add two dimensions. You can add only add or subtract add or subtract only same dimensions, but multiply or divide any dimension. This is known as principle of homogeneity. Now the most important topic is significant figures. The next most important topic. We'll do questions, don't worry. At the end I will be discussing questions. Significant figures. Right now you just try to understand what I'm explaining, the concepts. Okay. So significant figures are nothing but the figures that are very important for us. Okay, figures which are very important means what, until which level do I know the accuracy, until where I'm sure, what are the digits that I'm sure in an equation. For example, let me tell you something. Mm, less. So significant figures are nothing but, for example, when you talk about 1.07, okay, plus 1.2. When I add two numbers, for example, I get 2.27. Now the problem is, I was certain here only about two digits. Then how can my answer be more accurate than this? When here, when I'm adding two numbers, how can my final answer be more better than the this answer, which is less better? For example, for example, my weight is 55.5 kg. This is the weight that I measured first time. This is the weight that I measured again. Okay, second trial. I took two trials of my weight. First trial, second time again I measured my weight. Second trial, I measured my weight to be 55.4 kg. Now I am trying to find the average of these two weights. When I find the average of these two weights, I get 55.45 kg, right? Now my question is, my weighing scale. I have a weighing scale. My weighing scale can show me only one point. My weighing scale has least count of 0.5. My weighing scale can measure lowest 0.5. Then how did my answer end up to 0.05? Here the least count is 0.05. You're able to see here, right? You're able to notice here that here the answer is having one extra digit, whereas my weighing scale is not capable of measuring here any digit. It doesn't show anything here. Then how can my answer show one extra digit? How can it be more precise? Precision means up to how many digits you are able to measure, how close you know the value, how close you know value to something. Whereas accuracy means how many times the value is, how close the value is to the correct value. That is called accuracy. Okay, accuracy means how close the value is for correct value. Suppose my weight is 55 kg, so 55.4 is accurate because it is closer, whereas this is more precise because this is giving an extra digit. But this is not accurate. This is more accurate because it is 55.4, which is more closer to my actual weight. This is little extra. This is nearer to my actual weight. So that is the meaning of accuracy and precision. Now my question is, how can this value be more precise where my weighing scale itself couldn't show that? So that's why significant figures come into picture, so that you can retain the same number of digits until where you have certainty. Because I am certain only about one digit after point. According to my weighing scale, only one digit after decimal I am sure about this digit. If I write any other digit after this, all these digits I am not sure about them. So that's why these are called as significant figure. If you want to know the definition of significant figure, generally weighing scale also has one uncertain digit. Weighing scale, this is the error actually. So one uncertain digit, whatever the weighing scale can show me, plus other certain digits, that is known as significant figure. That is the definition of significant figure. Okay, so now there are certain rules for significant figure. First, let's talk about how do you count significant figures. Okay, so it's a very simple process. So suppose one thing, whatever zeros are there between non-zero numbers, these two are non-zero numbers, between this I have zeros, between this I have two zeros. These two zeros will be considered as significant. So total how many significant figures here? This question has four significant figure. Second part, 4.003. How many significant figures does this have? This also has four significant figures. It doesn't matter if you put a point in the middle. Ultimately, it's between two non-zero digits. Whatever zeros are coming before the number, whatever zeros are coming before the number are not considered significant. So this has one significant figure, only one significant figure. These are not considered as these numbers are not these zeros are not considered as significant because they are coming before the number. Okay, next, 4000. How many significant figures here? One significant figure. Whatever zeros are coming after the number also, they are also not considered as significant. And then if zeros are coming after decimal point, then it is considered significant. Then this is having two significant figures. Then the zeros are considered significant. Now these rules might be confusing to you. So the best way to do any question is, suppose I have 4030 and I want to show that all these four numbers are significant. So how will I show? Actually this is having only three significant figure. If I write it like this, it has only three significant figure. But how do I show it that exactly I am sure about this last zero? So what I do, I write it as 4.030 into 10 to the power 3. This is the way to write any scientific notation. One number followed by all the numbers after decimal point into 10 to the power something. This is the way you represent some significant figure scientifically. This is known as scientific notation. Okay, so scientific notation means scientific notation. Scientific notation of representing is one number or one digit followed by decimal point followed by a decimal point, one digit plus decimal point plus remaining digits. Plus means don't add. I'm just telling you how to write. Okay, let me just erase this plus sign. Some people will start adding it otherwise. Decimal point plus remaining digits into 10 to the power n. This is the way of representing something scientifically. Okay, scientific notation. Now last topic, the most important topic is last topic, which is nothing but vernier caliper and screw gauge. These are the two important topics. I don't have much time to discuss vernier caliper right now because this is a crash course. I cannot explain you in too depth the vernier caliper, so I will be explaining you shortly. Just pay a lot of attention to whatever I am explaining you. Okay, so basically this is how the vernier caliper scale looks. There is one main scale here. This is known as main scale. Above this you have a small vernier scale. Above this you have a small vernier scale. So our first step is, we need to check how many main scale divisions is equal to how many vernier scale divisions. See here, this is vernier scale, and this is main scale. So let me draw it properly for you. So here 1 2 3 4 5 6 7 8 9 10. Suppose 10 vernier scale here is equal to 1 2 3 4 5 6 or 5 6 7 8 9 10. 9. Okay, Okay, so here, how many vernier scales are matching with how many main scale? First step is that is the first step. Okay, so let's just count: 1 2 3 4 5 6 7 8 9 10. 10 vernier scales are coinciding. See here, 10 vernier scales are present. See here, there will be many scales. It is not just till here, there will be many scale, but this vernier scale is small. Main scale will keep continuing, but this vernier scale is present up till here. So until where the vernier scale is present still here. So still here, what is the divisions that main scale is having? That is the first step to count. So 10 vernier scale divisions is equal to how many main scale division? 1 2 3 4 5 6 7 8 9. So that is the first step. So write down: 10 vernier scale division is equal to 9 main scale division. This is the first step. All questions you are going to do like this. Okay, now you should know what is the value of one main scale division or one vernier scale division, any one. Okay, so they will give you what is one main scale division. One main scale division is, suppose, 0.1 centimeter. This is 0.1 centimeter. This is 0.2 centimeter, this is 0.3 centimeter, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10, like that. 0. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10. So this is 0.10. So that's how it is. So right now, one main scale division is, suppose, 0.1 centimeter, and 9 main scale divisions are matching. So multiply that. 9 main scale division into 0.1 is equal to 10 VSD. So here what do you get? 0.9. VSD is equal to 0.9 divided by 10, which is 0.09. This is how you will find vernier scale division. So one vernier scale division, how much did I get? 0.09 centimeter. That is the first step. Okay, don't get confused. See, I am telling you again. So each division here is 0.1 centimeter. So such 9 divisions are matching with 10 divisions of vernier scale. So 10 vernier scale division is equal to 9 main scale division, and one main scale division is 0.1 centimeter. So I am going to multiply that. So this is the total length. Total length of this is how much? 9 into 0.1, which is nothing but 0.9. So I will get 0.9 here, and this is 10 VSD. From here I can find one vernier scale division. So one vernier scale division is 0.09. Now least count. This is very important. Okay, least count. What is the lowest that you can measure in any device? That is called as least count. Least count of a vernier caliper is nothing but 1 MSD minus 1 VSD. So how much do you get here? 1 MSD you knew. 1 MSD was how much? 1 MSD was equal to 0.1. I wrote already. So 0.1 0.1 centimeter minus how much is 1 VSD? 0.09 centimeter I got. So the formula 0.09 centimeter. From here if you subtract both, you get 0.01 centimeter. This is the least count of my device. This is the least count of my vernier caliper. Now the way to take the reading is, let me write the formula. Reading is equal to, reading of vernier scale is equal to 1 main scale reading, not 1 main scale reading plus vernier scale reading into least count. Whatever least count you are getting from this formula. So first step is find least count using this formula, and directly they will not give you one main scale and one vernier scale in the question. They will either give you main scale or they will give vernier scale. Then you're supposed to find using this formula the value of other one. So first you find the value of one vernier scale division, put it in this formula, then subtract it from one main scale division, you will get the least count. Then put that least count in this formula and find the vernier scale division and vernier scale reading and main scale reading, and that's how you will get your final reading. So hope all of you understood this. I will tell you how it looks. How do you take the reading? Suppose my main scale shows like this: 5 centimeter, this is 5.1 centimeter, 5.2 centimeter, 5.3 centimeter, 5.4 centimeter, 5.5 centimeter. So this is 5.5 centimeter, right? This much you know to read. So this reading will be how much? This reading will be 5.5 centimeter. This is my main scale reading. Above this you have a vernier scale, which is going to have multiple lines, many lines. Vernier scale has many lines. So if you look here exactly, only one of the line of the vernier scale is going to coincide. Suppose this line. If you see here, if you look here carefully, see this line doesn't match with any line. This line doesn't match with any line. This line is behind this line. This line is middle of these two lines. This vernier scale line is between these two lines. This vernier scale line is between these two lines. But this vernier scale line exactly matches. This also doesn't match, this also doesn't match. So which line matches? 1, 2, 3, 4, 5, 6, 7, seventh line. Seventh vernier scale line is exactly matching. So my vernier scale reading is 7. My main scale reading is, sorry, this vernier scale should be here. Otherwise you cannot take the reading. This vernier scale will be here, starting from here. So my main scale reading is 5.5. Main scale reading is 5.5 centimeter and vernier scale reading is 7. And here if you see, here many lines will be present. Here exactly the 7th line is matching. Okay, 7th line is matching there. So from where the vernier scale is starting, that is my main scale reading, and which line of the vernier scale is coinciding with here some line, that line is considered as vernier scale reading. So this is how we take, and then substitute in this formula the values, and then you can calculate the readings. So this is how we do the questions from vernier caliper. Next we are going to see screw gauge. Screw gauge is very simple device. Screw gauge looks something like this. Here there will be a screw. So basically if I want to explain you properly, so this is my main scale. On top of this main scale a screw rotates. The screw will rotate, and the screw has 100 lines on top of it. The screw has 100 lines on top of it. Hundreds of lines. 100 lines on top of it. How much ever line it can have, it depends. So when this screw rotates one time, it covers some distance on this main scale. Suppose it covers 0.1 centimeter. Okay, how much does it cover? Suppose my screw travels 0.1 centimeter in one rotation. When it moves one time, when I rotate this one time completely, the screw, it moves 1 centimeter. So this 1 centimeter is known as pitch. So what is the meaning of pitch? Pitch means when I rotate the screw one time completely, how far does it go? That is called as pitch. Now how many lines does the screw gauge have on top of it? The screw gauge has many lines on top of it. So each line will be how much centimeter? See, when it is rotating one time completely, it goes 1 centimeter far. That means when I rotate one line, there are 100 lines on top of it. So 1 centimeter by 100, that will be the value of each line, right? So 0.01 centimeter. Each line means 0.01 centimeter, and this is called as least count of screw gauge. So least count of screw gauge is, what is this one? This one is nothing but pitch. What is this 100? Number of divisions on this circular scale. Correct. So the formula will be least count is equal to pitch divided by number of division on circular scale. And now to take the reading, it's same. Whatever formula you wrote there, reading is equal to, only difference will be main scale reading plus circular scale reading into least count here. That is the formula. So let's see some questions, you will be able to understand better. We'll do one or two questions and then we will wind up, so that we will do the questions later in some other day, but the concept should be clear. So that's why we will do few questions. Fifth division of circular scale and fourth main scale reading if circular scale has 50 divisions, then find the reading. One main scale reading is equal to 0.1 centimeter. So first step is, see, this is the question. The question is not clear, simply I have written something. So this is the thing that is visible on my circular scale. Okay, so basically I am supposed to find fifth division on circular scale means how much? That is the question. So fifth division on the circular scale means, first let's find least count. Least count will be equal to pitch. Pitch here is 0.1. This 1 MSR only is the pitch, because one time when I rotate it, it covers 0.1 centimeter divided by 50. So here how much do you get? 0.02 centimeter, right? 0.02 centimeters my least count. Now what will be my reading? Fifth division on the circular scale. So reading will be equal to MSR. My MSR is fourth. So fourth means 0.4 centimeter. Because 1 MSR is 0.1, fourth MSR will be 0.4 plus CSR is how much? Circular scale is fifth division. So 0.5. Circular scale reading is 5 into 0.02. That's all. 5 into 0.02 is 0.10. So 0.6 centimeter is my circular is my final answer. This is the reading. So this is how you are going to do the questions. For 1 year scale also same way you are going to do the questions. We'll see the questions later, but this is the entire chapter. Hope you understood how to do the chapter. So thank you very much. Do subscribe to the channel and don't miss out on the other videos.